Hello, viewers. In today's session, we are going to discuss an important problem from derivatives. And here we are going to solve this problem where the integral 0 to x f of t dt is equal to 2x cube minus integral 0 to x square f of t over t dt. Then we have to find the value of f of 1, right? So let us see how we can find out the value of f of 1 using Newton-Leibniz theorem. So let us first quickly see the statement of Newton-Leibniz theorem, and then we'll apply the same to this problem. So now consider this integral where the limits of integration are some functions of x. So here the lower limit is u of x and the upper limit is v of x, and now consider a function, say f of t, which is a continuous function in some interval, say a comma b, right? And let us differentiate this integral with respect to x, right? So here u of x and v of x are some differentiable functions of x. Then the Leibniz integral theorem says that d by dx of this integral is given by f of v of x. That is, first we'll replace this t by v of x, and then we write here d by dx of v of x, and then we have a negative sign. Then we have f of u of x. That is, now we'll replace this t by u of x, and we multiply this expression by the derivative of u of x, right? So now we have to differentiate this integral where the lower limit and upper limit are some differentiable functions of x. So d by dx of this integral is given by f of v of x, then the derivative of v of x with respect to x minus f of u of x multiplied with the derivative of u of x. So now consider the special case when the lower limit, that is u of x, is equal to 0, right? In the given problem here we have the lower limits as 0, right? So if u of x is equal to 0, then we can modify this statement by writing here f of v of x and d by dx of v of x, and here since u of x is equal to 0, so this entire term reduces to 0. So here now we have d by dx of the integral from 0 to v of x, and here we have f of t dt, right? So whenever we have an integral of this form where the lower limit is 0 and the upper limit is some function of x, that is v of x, then the derivative of this integral is simply given by f of v of x. That is, will replace first this t by this upper limit, that is v of x, and then we multiply this expression by the derivative of v of x. So let us apply this result to this problem by differentiating both sides with respect to x. So now differentiating both sides with respect to x, we have d by dx of the integral 0 to x and f of t dt, and then we have d by dx of 2x cube, and then we have d by dx of the integral 0 to x square f of t over t, and here we have dt, right? So now if we compare this integral with this one, then v of x is simply x. So applying this result to this integral, we have here for f of t as small f of t. So now we have simply f of x here and the derivative of v of x, and v of x is simply x, so the derivative of x is 1, right? And here we have 2 and the derivative of x cube is 3x square, and here v of x is now x square, so we'll replace all these t's by x square, that is f of x square over x square, and then the derivative of v of x, so we have here d by dx of x square, right? So now here this term is equal to 1, so we have simply f of x here multiplied with 1, then here we have 3 times 2 is 6, 6x square, and here we have f of x square over x square, and the derivative of x square with respect to x is simply a 2x. So now we can write f of x, here we have 6x square minus f of x square, here we have 2 and divided by x. So here this x and this x get cancelled, right? So now we have this expression, that is f of x is equal to 6x square minus 2 times f of x square over x. Now we need to find out the value of f of 1. So let us replace x is x by x is equal to 1. So here we have f of 1, then here we have 6 times 1 square, then here we have 2 times f of 1 square over 1. So we have f of 1, here we have 6, and here we have 2 times f of 1, 1 square is 1, right? So now we have a linear equation in f of 1. So taking this term to this side, we have f of 1 plus 2 times f of 1 is equal to 6. So this is 3 times f of 1 is equal to 6. F of 1 is equal to 6 over 3, that is 2. So the required value of f of 1 is equal to 2. So viewers, this is how by making use of Newton-Leibniz integral rule, we can find out the value of f of 1, and the value of f of 1 in this case is equal to 2.